These are the solutions to problems 19 to 21 on the kinematics problems. Number 19, a tennis ball is thrown straight up into the air with an initial velocity of 22.5 meters per second. It is caught at the same distance above the ground from which it was thrown. That's why my displacement is 0, because the displacement is how far it ends up from where it started, and when it was thrown and caught at the same height, that d is going to be 0. Find out how high the tennis ball rises and how long it remains in the air. We have to break this into two separate parts. The reason for that is we know the acceleration because it's free fall, negative 9.8 meters per second squared. We know the initial velocity. When we're talking about it going up and coming back down, displacement is 0. If we're talking about finding how high it goes, that's a maximum height. D is not going to be 0 then. That's when it's at a place other than where you threw it. So that's why we're going to break this into a separate part when we're trying to find the maximum height down here. So let's just worry about the time first. This is the total time that it spends in the air. We have the d, we have the v naught, we have the a. We're looking for the equation that does not have vf in it, and that's d equals v naught t plus 1/2 at squared. This is a quadratic, so we're going to have to use quadratic formula. We talked about that in previous problems. The quadratic formula for this equation is time equals negative v naught plus or minus square root of v naught squared plus 2ad all over a. We can plug in our numbers. Negative 22.5 meters per second plus or minus negative 22.5 meters per second squared plus 2 times negative 9.8 meters per second squared times 0 for the distance or displacement, all divided by 9.8 meters per second squared, and that's going to give us a time of 4.6 seconds. So that's the total time it spends in the air. You will get 2 times for that. You get 4.6 seconds and 0. Obviously 0 is not correct, so 4.6 seconds is what we're going to go with. Now we're going to try and find the maximum height. The initial velocity does not change, upward 22.5 meters per second squared. Acceleration is still downward, negative 9.8 meters per second squared. But at the maximum height, that's when the object stops for just an instant before turning around and coming back to the ground. So VF is 0. So now we're looking for the equation that does not have time in it, because we're looking for the d. So it's VF squared equals V naught squared plus 2AD. We rearrange that to solve for displacement, so we're going to subtract V naught squared to the other side, giving us VF squared minus V naught squared. Then we divide by 2a, and that's why they're in the denominator here. We're going to plug in our numbers like you see here. VF is 0, V naught is 22.5, and a is negative 9.8 meters per second squared. When we plug that into our calculator, we find the maximum height for the ball is 25.8 meters. Number 20. From her bedroom window, a girl drops a water-filled balloon to the ground 6 meters below. That's why this is negative 6 meters. If the balloon is released from rest, how long is it in the air? Released from rest means that the initial velocity is 0. You're not throwing it, you're just dropping it. And the acceleration of anything in free fall is negative 9.8 meters per second squared. We're looking for time, so we're going to use the d equals v naught t plus 1/2 at squared equation, because that's the equation without vf, which is the one that we don't know and don't care about. We don't have to use the quadratic because v naught is 0, so that term is going to cancel out, leaving us with simply d equals 1/2 at squared. We're solving for time, so we're going to multiply by 2 to get rid of the half. That's why you see 2d on the left side, and divide by a. That's why a is in the denominator, and we don't want the squared, so we take the square root. Plugging in our numbers, we get the square root of 2 times negative 6 divided by negative 9.8 meters per second squared, giving us a time of 1.1 seconds for this thing to fall and hit the ground. Number 21. At the beginning of a basketball game, a referee tosses a ball straight up into the air with a speed of 4.6 meters per second, so that's our initial velocity. A player cannot touch the ball until after it reaches its maximum height, so we're looking for the highest point that this thing's going to go, and then it begins to fall down. What is the minimum time that a player must wait before touching the ball? So basically this question is saying something gets thrown up in the air, reaches the maximum height, how long does it take to get to the maximum height? Initial velocity was given in the problem. Acceleration for something in free fall is always negative 9.8 meters per second squared. Final velocity at the maximum height is 0 because it has to stop before it can turn around and come back down. We're picking the equation without d in it because we don't have it, and that's going to be vf equals v naught plus at. We're solving for time, so we're going to subtract v naught over to the left first, giving us vf minus v naught in our numerator. Then we divide by acceleration, giving us vf minus v naught divided by a. We're going to plug in our numbers. 0 meters per second minus 4.6 meters per second, all divided by negative 9.8 meters per second squared, gives us a time of 0.47 seconds.